Assalamualaikum and hi everyone. Today we're going to discuss about learning outcome 5.2 question number 8. An average force of 50 Newton is used to compress the spring by 20 centimeter. If all the energy stored in the spring is transferred to a 25 gram pebble being fired vertically upward into the air, determine the initial speed of the pebble. So to answer this question, firstly, we need to use the conservation of energy, which is the sum of E initial equals to sum of E final. So E initial is equals to US. Okay, so remember, energy yang wujud hanyalah disebabkan oleh spring, potential energy bagi spring. And then the final energy is equals to the K final. Because at this time, hanya pebble saja yang bergerak. The formula for the potential energy spring is half kx square. Then the kinetic energy is half mv square. So we substitute all the information given. But before that, we need to find out the value of k. Because there is no value of the spring constant. So we need to find out the k. From F equals to kx, k equals to F over x. The force is 50 Newton and the x is 20 centimeter. We convert to meter. So we get the spring constant is 250 Newton per meter. After that, we substitute the value of spring constant into the general equation, and there we put the value of x in unit SI equals to half, mass is 25 power of negative 3, okay, gram, we need convert to kilogram, and then U. Okay, so lastly we get U equals to 20 meter per second. So inilah the initial velocity untuk pebble. And then find the maximum height reached by the pebble. So the maximum height reached by the pebble we can find out also from the conservation of energy. Sum of E initial equals to sum of E final. Okay, so di diagram dia, kalau kita lihat, pebble kita daripada initial point sampailah ke H maximum. So, kita akan assume di bawah ni adalah initial and H maximum ni sebagai final point. Pada initial point hanya wujud kinetic energy, but at the final point because ada H, so yang energy yang wujud adalah potential, gravitational potential energy. So we substitute into the equation. E initial is because of the kinetic energy, which is half mu square because initial velocity. And then at final point we have gravitational potential energy. So half, and we can cancel out left and right. So we calculate U is 20 from the previous answer, then G is 9.81 and H is equals to 20.4 meter. Now let's look at question number 9. A 1,500 kilogram car accelerates uniformly from rest to reach 10 meter per second in 5 seconds. This one is T. U equals to 0, then V equals to 10 meter per second, and the mass is 1,500 kilogram. Determine the average power delivered by the engine. We know that the formula for power is equals to work over T. Firstly, we need to find out the work. So the work is equals to delta K. Macam mana kita nak tahu nak guna delta K ataupun Fs? So kita tengok pada information given. So dalam soalan dia tak beri nilai F, dia tak beri nilai displacement. Tapi kita tahu kat situ dia ada mass, ada velocity. So kita relatekan work tu dengan work energy theorem, which is work energy theorem adalah sama dengan K final tolak dengan K initial. So initially kita tahu U dia adalah 0. So half mv square minus half mu square. Okay, so jadi kat sini U is 0. So means that the K initial tu akan jadi 0. So kita yang tinggal sekarang, work adalah equals to half mv square. We substitute all the information given and we can get the work. Work is 75,000 joule. So from P equals to W over T, 75,000 over 5, we get 15,000 watt or 15 kilowatt. Then number 2, the instantaneous power delivered by the engine at T equals to 2 seconds. Okay, to find out the instantaneous power, the formula is P equals to F dot V. F is equals to MA, then times the velocity. Mass is 1,500. So the A we need to find out, and the velocity also we don't have. Okay, so means that we have two unknown quantities that need to find out. Firstly, we find out the A, okay, by using A equals to V minus U over T. Then final velocity is 10, initial is 0, T is 5 seconds. We can get the acceleration 2 meter per second square. Okay, after we get the acceleration, we can find the velocity at T equals to 2 seconds. So V equals to U plus AT, U equals to 0, A equals to 2, T equals to 2. So we have 4 meter per second. Then we substitute into the general equation, substitute here, and then we can get the answer is 12,000 watt or equals to 12 kilowatt. Question number 10. Describe the energy transformation after the block is released until the spring is compressed to the maximum. So kita ada satu block kat sini with mass 20 gram. So kita compresskan block ni pada satu spring. Okay, at first the height is 0.25. Okay, ini adalah initial. So final, kalau kita lukiskan, ni yang telah berlaku. Di mana pada ketika ni dia masih lagi mempunyai nilai, ada H lagi lah, belum sampai, biasanya dia tak jejak ke bawah terus lah. Okay, let's say the H at initial point is equals to 0.25 meter and this one is X. Okay, so kita tengok initial dan final. So apa yang berlaku? So from the conservation of energy, explain qualitatively. Qualitatively means that awak kena nyatakan in sentence lah. Okay, so point dia kat sini. Okay, as the block falls, the gain in kinetic energy will equals to the loss in gravitational potential energy. When the spring is compressed, kinetic energy of the block decrease and elastic potential energy of the spring will increase. Therefore, the maximum elastic potential energy of spring will equals loss of the gravitational potential energy of the block. Calculate the maximum compression of the spring. So we apply the conservation of energy. Sum of E initial equals to sum of E final. So E initial kita ada mgh, sebab ingat kita ada height dekat sini. So block masih lagi tak bergerak, so kinetic energy 0. Spring pun tak ada compress, tak ada stretching, so dia akan jadi X ni 0. Okay, so yang wujud adalah satu, iaitu height. So kita masukkan E initial kat sini, hanya wujud mula gravitational potential energy, which is U initial. So finally, okay, kalau kita lihat sekarang, dia masih ada lagi height, and at the same time, kalau kita nampak sekarang, spring kita dah compress. Bila compress, maka akan wujud nilai X. Finally, the energy final is equals to U final plus US final. Then write down the UG ataupun gravitational potential energy is equals to mgh, K initial, and then the final is mgx. Okay, saya dah labelkan X tadi, dan U spring adalah equals to half kx square. Okay, so kita masukkan semua value. Okay, we substitute all the values into the formula. So we have now Okay, M equals to 20 power of negative 3, G is 9.81, H is 0.25 equals to M 20, G 9.81, X kita tak tahu, then plus half, K dia dah beri force constant is 85, X square. Then we rearrange the equation, we get 4.25 X square minus 0.1962X minus 0.04905 will equals to 0. So X equals to 0.03636 meter. Okay, now question number 11. Object P and Q of masses 2 kg and 4 kg are connected by a light string and suspended as shown in the figure. Object Q is released from rest. Calculate the speed of Q at the instant just before it strikes the floor. What we need to do is we relate the situation with the conservation of energy. Untuk jawab soalan ni, kita kena lihat objek P dan objek Q, initially dan pada final. So ini adalah initially. Okay, dan final ialah kalau saya lukis balik, bila Q dah sampai ke bawah, so P ni akan terangkat ke atas. Okay, kita nak tahu berapa speed of Q just before it strike the floor. Initially, kita kena lihat pada blok P dan blok Q. Okay, blok Q yang wujud kat sini dia ada gravitational potential energy. Kinetic energy Q ni tak ada. Elastic potential energy tak wujud. Dan pada point P, H dia 0, so U, P dia pun 0. Tak ada. So, kinetic energy pun 0 sebab belum ada movement. Spring pun 0. Okay, itu adalah untuk initial. Dan final point, untuk objek Q, the gravitational potential energy is equals to 0. Okay, sebab H dia 0. Tapi dia masih ada lagi kinetic energy. Sebab pada ketika dia masih lagi bergerak. Dan kita nak tahu berapa final velocity tu just before it strike the floor. Kemudian spring memang confirm dah tak ada. Objek P mempunyai nilai H. U, P wujud. Itu gravitational potential energy. Kinetic energy pun wujud. Okay, U spring tak ada. Okay, so kita dah conclude kan, inilah energy yang wujud, okay, initial dan final. Okay, yang pertama kita ada initially, this one UQ. Then final kita ada UP, KP dan juga KQ. So kita masukkan dalam conservation of energy. Initial we have UQ, final we have UP plus KP plus KQ. Okay, masukkanlah semua value. UQ adalah MQGH. UP adalah MPGH. KP adalah half MPV square and KQ is half MQV square. So we substitute all the values. Okay, the MQ is 4, G is 9.81, H is 2 equals 2 times 9.81 times 2 plus half MP is 2V square plus half 4V square. So lastly we get V equals to 3.62 meter per second. So inilah jawapan untuk question number 11. Okay student, that's all for learning outcome 5.2. Bye!